Hello, class. Last class, we looked at graphing linear inequalities in one variable. Today, we're going to look at solving linear inequalities in one variable. Let me give you a few examples first, and then we'll talk about how we can solve them. So we can look at 8 minus 3x is greater than or equal to 20. We could look at 3 times x plus 4 is greater than x minus 5, and x over 2 plus 4 is less than or equal to 3x minus 4. All of these are examples of linear inequalities in one variable, and before we can graph them, we need to solve them, which means we need to get the variable alone on one side. It's very similar to solving equations, and in fact, the rules are exactly the same with just a couple of small exceptions. To solve inequalities, we may use the same strategies as when we solved equations, except we must change the direction of the inequality sign when we multiply or divide by a negative number, or if we switch the two sides of the inequality. Let's go through these examples one at a time. For each of these, we're going to solve, graph, and express in interval notation, getting practice with all the things we learned last class. Let's start with 8 minus 3x is greater than or equal to 20. We want to isolate the variable, just like we would in an equation, so we need to get this x by itself, which means we need to get rid of this constant term. To do that, we subtract 8 from both sides of the equation. When we do that, on the left, it leaves us with negative 3x, and that's greater than or equal to 20 minus 18 gives us 12. Now we need to get the x alone. To do that, we need to divide by the negative 3. But I want to point something out here. We are dividing by a negative number, and we know that if we multiply or divide by a negative number, we must change the direction of the inequality sign. So when we divide by a negative, this greater than or equal to sign turns into a less than or equal to sign. All right, negative 3x divided by negative 3 leaves us with just x. 12 divided by negative 3 is negative 4. And we've got x on its own, so the solution here is x is less than or equal to negative 4. This is how we solve inequalities. Just like equations, except there are a few instances where we need to change the direction of the inequality sign. Now that we've solved it, we can graph it. I'm going to draw a number line that includes negative 4 on it. Negative 4, negative 2, 0, 2. I generally will draw number lines that include the important number here in our answer and also the number 0 just to give some context. Now, x is less than or equal to negative 4. Less than means we need to shade to the left of negative 4. So I'm going to shade everything to the left. And because it's allowed to be equal to negative 4, that means that I'm going to put either a closed circle or a bracket. Either method is fine. I default to open and closed circles, but you're welcome to use brackets and parentheses. So here we have our graph. We've got the solution. We've got the graph. Now we need to express it in interval notation. If you look at this interval, it goes all the way to negative infinity on the left, and on the right it stops at negative 4. It includes negative 4, so we put a bracket there, and then with negative infinity we use a parenthesis. Always we use parentheses with infinity and negative infinity, and so our interval notation is going to be parenthesis, negative infinity, comma, negative 4, bracket. Good. Let's jump straight into the next one. 3 times x plus 4 is greater than x minus 5. Here we can simplify the left-hand side with the distributive property. That gives us 3x plus 12 is greater than x minus 5. Now we've got variable terms on both sides. We need to eliminate one of them. We can eliminate the x by subtracting x from both sides. That gives us 2x plus 12 is greater than negative 5. All right, we need to get rid of that 12 term. We can do that by subtracting 12 on both sides. This leaves us with 2x is greater than negative 17. And when we divide by 2, this gives us x is greater than negative 17 halves. Now, we need to figure out where that's going to go on our number line. If you use a calculator, you can see that negative 17 halves is the same as negative 8 1/2. So what I'm going to do is I'm going to draw a number line that includes negative 8, and negative 8 1/2 is halfway between negative 8 and negative 9. So we're going to put an open circle, because it's not allowed to be equal to that number, halfway between negative 8 and negative 9. And then for shading, because x is greater than that quantity, we're going to shade to the right. So it's going to look like this. Very good. And now in interval notation, we have parenthesis for the open circle, negative 17 halves, comma, infinity, closed parenthesis. All right. And we've got one more. I'm going to write it up here. X halves plus 4 is less than or equal to 3x minus 4. Here we have an inequality with a fraction in it. Just like an equation with a fraction, we know we can get rid of it by multiplying both sides by the LCD. In this case, the LCD is 2, because that's the only denominator. Now let's go through and distribute that 2 on both sides. 2 times x over 2 gives us just x. The 2's cancel. Plus 2 times 4 is 8. On the right, 2 times 3x is 6x. And then minus 4 times 2 gives us 8. Now we have variable terms on both sides. We can eliminate the x by subtracting x from both sides. That gives us 8 is less than or equal to 5x minus 8. We want to get the 5x alone. We can do that by adding 8 to both sides. That gives us 16 is less than or equal to 5x. And we divide both sides by 5, giving us 16/5 is less than or equal to x. Now, one quick thing I want to point out, when we're dealing with inequalities, it's usually easier to have the x on the left-hand side for graphing purposes. If we switch the two sides and put the x on the left and the 16/5 on the right, remember, we're going to have to change the direction of the inequality sign because we've switched the two sides. So instead of less than or equal to, it's going to be greater than or equal to. So we've got x is greater than or equal to 16/5. If we use a calculator to evaluate 16/5, we can see that that's equal to 3 1/5, or 3.2. So our closed circle, we need a closed circle because it's allowed to be equal to, is going to go at 3.2. And because x is greater than or equal to 16/5, we shade to the right. And if we write this in interval notation, it's going to give us bracket 16/5, comma, infinity, parenthesis, and that is our final answer. Take a look at some of the linked videos below to look at more examples and get more practice with this topic.